Let me welcome you to the 14th lecture of NPTEL online certification course Underground Mining of Metalliferous Deposits. We are discussing about the access to the mineral deposit, and in this lecture we will cover the incline shaft, that is the shaft constructed from surface to the underground in a incline direction, that is called incline shaft. We will discuss about its construction and other features in this lecture. But as we do in every class, let us look one again into this learning background required for the participant of this course, and these are the set learning objective of this course, and these are the expected learning outcomes from the participant of this course, and these are some of the text and reference books, and these are the learning objective of this lecture. We would like to understand the excavation techniques of incline opening, and we will also learn the different unit operations associated with this incline excavation, in particular to the excavation, then removal of the excavated mark, and followed by the supporting system, auxiliary other features, that is ventilation, extension of the power cable, etc. We will discuss this in this lecture. So, first let us understand what is incline shaft. Incline shafts are driven at an angle with the horizontal, and remember this angle has to be maintained. So, this angle is a consistent angle throughout the excavation of this shaft. This angle is maintained. The reason behind that, the transporting medium set in this incline will hinder if the angle is changing. So, to avoid that one, we usually give a consistent angle, constant angle, so that the whatever the transporting medium is placed, in general it is a rail mounted skip are provided. So, the operation of that should be well maintained, and for that we keep the angle constant throughout the incline opening. Often we go for some wide width of the incline. There we provide different compartment for the railway track and different compartment for the man and other material movement. And this is, you can see one photograph taken from the web source. You can see this consistent angle is maintained, and the excavation is carried out, but this angle is maintained so that the rails can be properly positioned in this, and in the side way the walking ramp can be provided or walking steps can be provided. So, this is in general an incline shaft. You can see this photograph of one incline shaft, where you can see that this is the opening. You remember these openings are called portal. So, this is the portal of the incline shaft. In this figure, this is the incline shaft, and you see the rails are provided in this shaft, and we allow this type of wagons or skips to move on this. If we are using this type of wagon, we call it a rope haulage. If we are allowing skip, which is automatically unloading systems are provided, then it is called skip transportation system, but both are running on the rails, and in general we provide like this, and this is the space provided for the walking of the personnel of the mining personnel, and generally depending on the slope we provide the steps or the ramp in this particular case. So, if you see this if in this beautiful photograph of the incline, this is the vertical shaft is showing, where you can see the cage is being lifted with a winding system. Here also we are providing the winding system in a similar way. So, either we provide a conveying system, this is a conveying system, bucket type conveying system, or we can provide a skip at this position. This type of conveying system is possible when the inclination is less, but for high inclination we have to provide the skip only. So, this is the general features of a inclined shaft. Now, this is the photograph of the skip. This is very important photograph, and I would like to draw your attention. You can see this is the skip, this is the skip pulling system. So, this pulling system is provided, rope, winding rope is attached to this, and this rope is basically pulling this one, and this can move on the rail, and the material is placed at this position. So, this is filled with the material, and this is having the benefit, it can slew in both this direction. So, this attachment, handle attachment can slew in both the direction, and you can see now particularly these two wheel, this one and this one, you can see the width of the wheel is bigger in this case, and here it is smaller. So, this is intentionally kept like this. You can see in the previous photograph, let me go back to that previous photograph once again. You can see here only two lines are available, railway lines are available. Now, if you look into this, in this case you can see this is the unloading system, where this one line and this two lines. So, instead of two lines we are having four lines. So, we are having some additional line outside the main line. So, when it was coming from the underground, these two original lines are there. These additional lines, these two additional lines are attached when we are going to unload this one. The reason is that when these two lines were only available. So, let us find this one and this one, these two lines are available. So, these widths are provided, width between two lines are provided like this. So, our both the wheels can stand on this and can move on this. So, this is for this two line, inner line, this is basically running on these two inner line throughout the inclined shaft. But when the unloading conditions are there, we provide this second line at a little bit away from the first line, so that the second wheel, this wheel will run only this on this second line, but first wheel will miss this one. So, first wheel will follow this line. So, when the case of unloading is there, the skip is allowed, the second wheel will stand on this position, that time the first wheel will stand on this position. So, automatically the skip will take a tilting shape here, and this will automatically unload the material in this position. So, that is why this is the special technique of unloading, automatic unloading of the skip can be carried out very easily by providing two different width of the wheel. So, this is the special technique in general followed in the skip transportation system in case of inclined shaft. This is not possible in the vertical shaft. So, this is the inclined shaft transportation system using the skip, this can be possible. Now, let me guide you to a tour in the incline shaft, and you can see in this case the skip is used as a man riding system. So, this person is moving through the by sitting in the skip only. You can see all the sides, you can see this goalpost support is also there. So, this is called goalpost support. These are the signaling cable. And this is the excavated roofs. It is carried out by drilling and blasting method. And this rock is seemed to be very competent, and occasionally bolting etc. are used as the support, or goalpost. Here the goalposts are used as the support in some cases. So, you can see this is the wooden goalpost support is provided. So, this is the roof condition. So, these are closely spaced goalpost supports are provided, wooden goalpost support. Now, it is almost reached close to the face where the incline excavation is going on. So, this is the face up to which this skip is provided. Then from the skip you can see the face operation is going on. And this is an extremely manually operated face. So, you can see this is the drilling is carried out, and also manual digging is also carried out. So, here the compressed air operated hammer bit is used for breaking the rock, and the broken rocks are manually taken out and loaded into the skip, and skip is taking out this material. So, this is the one very manually operated incline shaft construction is showing in this video. Now, if you think about the construction procedure of the incline shafts, you will find out this can be two types. One is discrete method of excavation carrying out by drilling, blasting, loading and transportation, and this obviously also associated with the auxiliary operations, and like say supporting, pumping. As it is excavation is carried out in the underground, water accumulation must be there. So, pumping is required, then ventilation is required. So, ventilation air duct has to be extended, electrical installations has to be extended, compressed air pipes has to be extended. So, all these, and apart from that lighting etc. must be there. So, these are the auxiliary operations to be carried out, and alternatively large diameter drilling is also possible, but in this lecture we will not cover it. In case of winging we will discuss the large diameter incline drilling from the top surface to the bottom surface, how that can be carried out, we will discuss that. So, in this lecture we will concentrate in the drilling and blasting system. So, this is the excavation towards the bottom side. So, that is why whatever drilling has to be carried out, this drilling has to be carried out at an incline angle towards the floor, and that is why there are different possible drilling pattern can be carried out. So, drilling in general in incline shaft mostly carried out with handheld drill machine. like jackhammer or electrical handheld drill, or if the openings are of significant large dimension, in that case the wagon drills are used, like your boomer drills are used. In fact, we will discuss this type of drills, which are basically possible by using the hoisting system. This can be lifted out after the drilling. So, this type of drills are also used in drilling in incline shafts. So, these are the drilling machines used. Drilling pattern used are either wedge cut or band cut. In general, wedge cut is very widely preferred. So, as you consider, this is the incline. So, generally wedge cut drilling is carried out. Using this type of pattern, and if the hard rock condition is there, sometimes a pilot hole of shorter length is provided here. So, this is the general wedge cut designing pattern. In fact, in our earlier drilling and blasting technology NPTEL course, wedge cut designing is described in detail. So, that can be also followed during this incline excavation. Alternately, band cut blasting can be practiced. In this case, wedge cut is mainly main popular hole drilling pattern, but in case of band cut blasting, this type of one empty hole is provided and then parallel holes are drilled. However, this empty hole which is provided generally, as this is the bottom part where the water is tend to be accumulated. So, whenever the drilling is carried out, it is a, for all the cases wedge cut and band cut, it is a likely chances that these holes will be filled with the water. So, water resistive explosives should be used in the blasting, and then the blasting has to be carried out. So, irrespective of blasting pattern, generally this is the blasting procedure carried out, and the blasting is carried out after shifting the manpower into the surface, and the connecting cables are transferred to the surface, and blasting is carried out from the surface only. During blasting, no one is allowed to stay inside the incline. Then marking is carried out using the cactus grab, and generally these cactus grabs are also shifted every time from the surface or any platform kept inside the incline time to time at distances. Say in general, some portals are kept. So, this type of platforms are in general kept time to time. So, in case of blasting, this cactus grab etcetera are shifted at this position, and when the blasting is practiced at this place, then again this is taken out at this position, then the marks are taken out using this cactus grab, and transportation generally practiced using the skip, temporary skip installed in the hoisting system. So, this is in general provision during the excavation. Along with that, the rails are provided, so that the skip is allowed to move on this rail, and whatever excavation is carried out, that can be taken into the skip and that is taken out. And in time to time interval, those platforms are provided at different levels as the storage place and machine shifting place that can be utilized. The auxiliary operations are also carried out, where the main is that ventilation duct has to be provided and extended after each blasting. Then those compressed air cable has to be extended, electrical lines has to be extended, lighting has to be extended. So, these are basically different auxiliary operations to be carried out in the incline opening construction. So, you can see this is the drilling. After drilling, the blasting is carried out, then the blasted marks is taken using this skip, and the empty skip is returning back. Again, the either it is a manually loaded, as we have seen in that video, or a mechanized system like cactus grab, etc. And in some cases, if a large opening is there, in those cases excavators are also, small excavators are also used. So, these are the different techniques of excavation in the unit operations in the incline opening. Now, let us once look into how the portal and excavation is made. Say suppose in this case the excavation has to be carried out. So, these are the first ground installations has to be made, different facilities. Then this is the surface excavation is made, box is created. Then from the box supporting has to be made side of the box, so that it will not fall down. Then gradually the excavation are deepened, so that the portal can be made. So, now the position of the portal is fixed. So, these are the supporting system made, concreting has to be carried out. So, this is the construction of the floor, and this is the supporting system of the portal. So, here it is showing arch support, and which is also covered with the concrete. So, as they are using conveyor system, so that is why double deck is made in this case. So, now this attachment to take out the material to the surface is extended. So, now as excavation is going on, material is placed to the conveyor. Now, conveyor is unloading the material. So, here the transporting system is installed is the conveyor, and this is the permanent supporting system with concreting is provided. So, as the excavation is going on, the incline is also being extended in the front direction. You can see these are the ventilation ducts provided, and along with that the electrical cable etc. are also extended time to time. So, excavation is going on, and accordingly the extension of the ventilation duct, extension of the supporting system is carried out in this case. So, this is more or less about the excavation of incline, but let us discuss what is happening on which case in general we opt for incline opening. Generally, if we are having the incline deposit, we go for incline opening. The reason is that we will follow the ore body. You can see in this case we can follow the ore body, and then our cross cut distances will be minimum. As the cross cut distances will be minimum, the transportation cost in the cross cut will be minimum also. So, we are having two different options. So, suppose this is the deposit, either we can have vertical shafts like this, or we can have single vertical shaft, or we can have an incline opening like this. So, these are having different conditions. One is that the construction cost of this one. So, this is one, or we can have the construction cost of a single shaft like this, or we can have the construction cost of a single incline like this. So, these decisions what we will opt for, whether a vertical shaft we should go for or the incline shaft we should go for, depending on the cost calculation. These costs are comprising, one is construction cost, and second one is the transportation cost. So, we can understand construction cost of this one is minimum, and this one is a little bit high, and this one is also high. So, construction cost is minimum here, but this is associated with construction of so many cross cuts. So, though the construction cost of the shaft is less here, but construction cost of the cross cuts are high in this case. In this case it is little bit high, in this case it is minimum. So, these are the comparison of the construction cost for shaft and as well as the cross cuts, and after that the transportation cost, whenever we are discussing in the transportation cost, it is in ton kilometer. So, whatever cross cut lengths are there, that is basically adding as a multiplying. We can say the cross cut length into x is the transportation cost. So, this transportation cost plus construction cost and the maintenance of the constructed openings, these are considered, and whichever is coming minimum, that is in general adopted. But there are some important issues, that is that if it is a very deep seated deposit, it is not wise to go for a single opening. The reason is that if the single opening is there, then as the upper level and lower level, these levels are operating, that means this portion and this portions are under operation. In those cases, if this is both are basically served with a single transporting system, then the transportation costs are increasing. The reason is that generally in mining, is multi-level mining, the transportation system is practiced by sending all the ores towards the transporting level. So, transporting level means we first send all the ores from this portion, this portion, this portion at this position. So, we provide a ore bin here, and in this ore bin we accumulate the ores there. Then from this we take out this ore through the shaft. So, the transportation in general is kept from the bottommost level from which the shaft is serving, and by this way we are taking out this material. Now, material transportation from this to this is gravitated down, it is not costing a lot, but transportation of material from this to the surface is the additional cost. So, the material of this position, transporting that from this position is a little bit costly in, if you are considering it is in the total mining cost. So, in general for this the upper levels are often served with a shaft of smaller depth, and lower level operations, those materials are taken out and those are shifted to this shaft. So, that can be taken out from this. So, this is basically reducing the transportation cost, and this type of considerations are called two stage winding or compound shaft condition. So, here we are having the option, either we go for two vertical shafts, or we can go for one vertical shaft, one incline, or we can have two incline, that is up to this one, then we shift that incline to another incline. But generally if the deposit is not very incline, we do not go for the incline, because incline is an additional cost because its length is increasing. So, suppose the incline has made at 30° angle and the depth is 200 meter, then you have to construct 200 by sin 30. So, that is 400 meter shaft has to be constructed. So, that is why generally incline shafts are longer in length, and it is in general not opted for. As it is longer in length, it is taking more time for the movement also. So, that is why it is not very much accepted, and generally we in those cases for very deep seated condition we go for two stage winding. This is also benefited that our winder size has reduced, because the length of the wire is reduced. So, the winder, a small winder can be placed here at small here, but in this case we have to provide a big winder, so that can take the load of this complete cable. So, that is also benefit of two stage winding, and moreover it is providing us the maneuvering, that is the alternately this can be and this can be run differently. So, these are basically opted. Two stage winding is opted where ore body is deep seated, inclination is moderate, and this decision must be taken with the comparison of the costs. So, these are different example of the two stage winding. So, this is one incline and two stage winding comparison. So, we have to consider shaft cost, we have to consider the cross cut cost, and apart from that we need to consider the cost of the transportation. So, this cost comparison is shaft cost for single shaft, for single incline shaft cost, for two stage incline, two stage vertical plus incline, but shaft vertical shaft cost, incline shaft cost, vertical and vertical, this is compound shaft condition. This is a vertical shaft cost, and this is the cross cut cost between the two vertical shaft, as we have seen in the previous case. You can see the cross cut is required here. So, that is why this has to be, construction cost has to be considered here. Now, the cross cut required here is shaft to ore, here also shaft to ore, here also shaft to ore, but here cross cut shaft to ore and plus cross cut shaft to shaft. And transportation cost, in general we are having transportation either skip or haulage. So, whatever it is we have to consider in this case. Here also it is the same case, and here one skip is in vertical shaft, another skip in incline shaft, and haulage whatever is required, or in this case skip and skip in vertical shaft, or we are having haulage and conveyor in the cross cuts we have to provide. So, the total cost is construction cost plus transportation cost. These are the cost analysis. Apart from that, we have to consider the maneuvering. That means, in two stage winding we can stop or we can have maintenance in one shaft, but that will not stop the production. Another shaft can can be under operation, and that can take the material. So, that is the benefit of two stage operation, which is not possible in single stage, single incline, single vertical shaft. Those are the problems. So, that is why these are sometimes often two stage winding is opted, and two stage winding must be carried out for very deep mines more than 400-500 meter depth, that must be carried out with two stage winding, so that the transportation cost and construction cost can be kept limited. So, that is more or less about the incline excavation, but before completion let us have solve one problem, how we decide the capacity of a shaft. Say if we are having an incline of 30° angle fitted with two skips, that means the counter load is also kept as a skip and serving 200 meter depth. Acceleration is I think 1 meter per second square, constant speed is 10 meter per second, and available hoisting hour per day is 15, and we have to decide the capacity of the shaft. So, with this data let us go for understanding this one. So, we are having an incline where these two tracks are provided, and these two tracks are alternatively having two skips. So, one skip when at the top in one track, another skip is at the bottom of another track. So, both are moving simultaneously. So, this skip is unloading, this skip is under loading. So, this is moving like this, and that time this is coming down like this, and when this skip is under loading, this skip is under unloading. So, this is the consideration of this problem, and considering that if we try to solve this problem, we can see we are having depth of the shaft is 200 meter, inclination 30 meter, acceleration deceleration 1 meter per second square, maximum speed 10 meter, loading unloading time is considered 2 minute, and skip capacity 10 minute, daily available utilized hoisting hour is 15. So, our acceleration time is 10 second to reach the 10 meter per second velocity. Similarly, deceleration time is also 10 second. Length of the incline, as it is 30°, it is 400 meter, and length of acceleration, that means during acceleration the travel length is 50 meter, during deceleration the travel length is 50 meter, and length traveled at constant speed is 30 meter. So, the 30 second time is required to move in constant speed. So, total time of travel is 50 second, and total cycle time is coming 220 second is the total cycle time. So, that is 50 second plus 50 second plus 120 second is the loading unloading time, and by this time our total production is 20 ton from the two skips. So, in this consideration we can find our total hoisting capacity of the shaft is becoming 5000 ton per day. So, this is all about one calculation. You must remember, if we are considering two stage winding of two vertical shaft, we have to consider the cycle time for this one, cycle time for this one in hoisting, but remember the cycle time for this one is not required, because this is serving with a storage position here, and this is also serving with a storage position here. So, whatever cycle time is required for of the material for the material movement from this shaft to this shaft is not hampering the cycle time of the operation. So, that is why this is not coming within the hoisting time. So, that is why it is not to be considered. So, that is very, very important in this calculation, that has to be remembered. So, this is all about the incline shaft and two stage winding. Thank you.